We're going to start off with chapter 2 here and deal with relations and functions. You should have talked about this for a couple of years now. But the big key is that a relation is a set of ordered pairs, okay? Okay, so that means that everything we talk about today, x, y, x, y, x, y, right, 1, 2, 2, 3, whatever you want it to be, that's always going to be a relation. The question today is, when does it become a function? Okay, just to clarify a few other things, the domain, those are the x values, and the range, that's the y values. So we'll continue to build on that this year and see what that means. If it's a set of ordered pairs, it's super easy. If it's the graph of a line, okay. If it's the graph of a parabola, if it's the graph of the square root, right, then we start to deal with all these different domains and ranges. So those are some things we're going to work on this year, but we're just going to set the table today. All right, so let's come up with a relation. Okay, so said 1, 2, maybe negative 3, 5, 8, 7, and let's go with negative 2 with, let's throw a 5 in here. So the question today, again, is it a function? So hopefully you remember the most important thing to look for is all of your domains, all the x values. Are they all different? Yes. So that means that this is, yes, it is a function. Okay, so that's the very first thing we're going to check for. If they do repeat, okay, so let's take 8. So now I've repeated 8. If I have exactly the same ordered pair, that's okay. So this is still, yes, a function. Okay, but as soon as I do this, 8 paired with 5, now this is no, it is not a function anymore. So we're going to show that using a map as well. Okay, so my map, my domain values, I'm going to put in here, right? So these are my x's, 1, negative 3, 8, negative 2. And my range values was 2, 5, 7, and I already have a 5 in there, so I don't need it. So the map physically shows these arrows going from the x's to the y's. So we have 2, right? That came from 1, negative 3 went to 5, 8 went to 7, 2 went to 5. Okay, so remember this was the yes. So I'm going to use yellow highlighter again. These are all okay, right? Because each thing in this domain map, right, this is called a map, each thing has one arrow coming out of it. So I'm looking right here, and that means every domain has one range. So let me add on the other one. So we're going to go with 8, 5, right? So this is the one that was a big no. So I'm going to keep this red on here. So that means I went from 8 to 5. Okay, so this is what you're looking for in a map. This section right here where it shows 2 arrows leaving a range or a domain value to go to different ranges. Okay, so this is what you're looking for a no. Again, if there's one arrow, it's yes. We started off with that one. Instead of making a whole nother one, we're just going to build onto this one. Okay, so those are the keys of what we're going to look for. All right, let's try it again. All right, got some numbers on here already. So we're going to go ahead and pause and jot the numbers in there. Domain, all the x's. 5, negative 2, negative 3, 4, 121, 0. All right, so we map them over. Okay, now you may find that they are written in order, least to greatest, stuff like that. So they might crisscross anything else, but if you just have to make one, we go straight across here. So first question is it a function? Okay, so first test was without the map, all the x values are different. So yes, it's a function. Okay, the other way that we look at it is, remember, all of these domains have one arrow coming out of it. So yes, it was a function. Okay, so I should be able to give you one or the other. You don't need both. So your true test is, can you identify an ordered pair? So you're going to make something up, x and y, so that this is no longer a function. Okay, if you can do that, then you understand what's going on. So pause it, think about it, write your number down, and then come back. All right, hey, welcome back. So the idea is that you used any of these domains. I'm just going to take the very first one, 2, and the idea is I cannot use 5, right? I have to use something other than 5. So even if I just went to 4, this is no longer a function. Okay, so if you have that idea, that's good. So this is our no, it's not a function, but remember it's still called a relation. Everything we talk about is still a relation because that's just a set of ordered pairs. All right, so here's what it says in your textbook, and this is what we try and stay away from. I want you to understand it, and you don't need to know the actual words from the book. When each element of the domain, remember that's your x values, is paired with one element in the range. Okay, one element in the range. Okay, that's your y values. Okay, so it can't be paired with 2. So that idea of 4, 5, and 4, 6, okay, that domain is paired with 2 different things. So that's why it's not a function. Okay, where in the world does this relate to? We have a couple ideas, right? You go out to eat, you get a menu, right? So here's your menu. You got some food, it's $4, something else, maybe that meal is $5, this one's $4.25. Okay, so all these meals that we have, these are X values, right? They're domains. If the restaurant is good at what they're doing, or fast food, or whatever it is, are these repeated anywhere? Like if this is a hamburger for $4, does down here it say hamburger for $4 again? No, right? So that means your menu items, right? A menu, that should be a function, right? Because we're going to talk about food is related to a price. Now, is there a chance that some of the items on there are the same price? Yeah. Think about like McDonald's. They're not paying me for this video, but your dollar menu or whatever it is, right? There are multiple things that if I started and said $1, you can get a small fry. Or for $1, you can get a small shake. Okay, so all those things. So if we look at it from the price and go over to the food, okay, we could accidentally make this into a relation only. They're related, but it wouldn't be a function because that dollar can go to multiple places. All right, so we're going to try and keep that in mind. Although this seems like a very just classroom type of thing. We have a little bit of stuff going on. All right, so next thing we have is, I thought I had another one of those over there. We got this. All right, so how's this old school picture? How is this a function? Okay, so we'll help guide you thinking a little bit here since you're on your own today. And just say, all right, so you have one teacher, right? So you have the teacher has student 1. Okay, so we'll just go across the front row. This is student 1, this is student 2, this is student 3 in class. And the teacher also has student 2, and the teacher has student 3. Well, student 1 has teacher, student 2 has a teacher, and student 3 has a teacher. So it's the same situation, but I can think about it by flip-flopping my domain and range. So one of these is going to be a function, and one of them is only a relation. So which one's which? So notice the one on the left here. The teacher is repeated with different students. So this is a relation. Remember, the teacher would have to be matched up with different, or each student would have to have a different teacher here for this to work. Okay, think about the map. This would be teacher, student 1, student 2, student 3. 1, 2, 3. So this has 3 arrows out of it, which is much more than 1. So that definitely doesn't count. Versus the one where we start with the student, that student has that teacher. Okay, that's it. This is a one-room schoolhouse. That's why I chose this old one, right? So that's the only relation there. So the student 1, student 2, student 3, these are our domains. They go to the teacher. Each of these students only has 1 arrow. So we want to make sure we understand it from both sides, whether it's just the ordered pairs or from the map. But this one here is a function. All right, so hopefully that clears some of that up. Okay. Now that we have some of that idea from ordered pairs, now we're going to give you some equations, right? So this is a linear equation. Hopefully you remember this from Algebra 1. We're talking about y equals mx plus b. So I got 1, 2, 3. We got a slope. So from here, we're going to rise 2, run 1. We get these 2 points. We're going to connect them. Look at that positive slope line. We're in good shape, right? Because I could simply say I'm going to plug in 0 and get 3. If I plug in 1, I get 5, dot, dot, dot. But I have to go through all the ordered pairs. That seems like it's going to take a long time. I would like a second way to do this. So to do that, we're going to graph it. Or we'll take a look at the graph if we already have a graph. And then what we're going to do is we're going to put a vertical line down through it. Okay, so this is the vertical line test. Vertical line test. And that means we want to hit once and only once. If that happens, it's a function. Okay, so my red vertical line crossed over my line one time. Guess what? It's a function. That's a lot faster than writing down all of the ordered pairs that ever existed for this function. Okay, vertical line test, once and only once. All right, so quick quiz here. Go ahead and circle which one is not a function and give yourself a little metacognition, right? Think about why is it? Why is one of these not a function? We'll check that out in your notebook then. All right, so an extra space so you can think or write. And then back to that vertical line test. Okay, so if you needed more time to pause and answer the above questions, please do so now. All right, welcome back. We're doing the vertical line test. Right, this is what we said, once and only once. If it hits it once and only once, it's a function. Okay, so I'm going to jump to the picture on the right because it's super exciting because it's already there. Right, so here's my vertical line once, twice. Remember, this is the x-axis and the y-axis, so those don't count. But it hits 2 times. It's not a function. We still have a name for it, though. What's that name? It's a relation. All right, let's take care of this one on the left. I tried to put it off as long as we could. I promise I did. But it's an x squared. Okay, so we got to remember what in the world that looks like. So hopefully COVID didn't cut that out. 1, 2, 3, 4. So I have a y-intercept at -4. It's an x squared, which means it has to be a U shape. This one is +3. So that means it's going to be super duper tall because it's been vertically stretched. All right, now if you didn't know what it looked like, obviously you're just going to throw in 0, get -4, plug in 1, and you'll get -1. Right, we can just make a table of values, x, y, and work through that. What I would encourage you to do is also try a -1 when we get things that are squared or absolute value, just so we also see the left-hand side of what's going on. All right, so now we have this parabola, this U shape. Here we go, vertical line test. How many times did I hit? Once. What's that mean? It's a function. Okay, so we're looking for a function. All right, there we go. I got a circle over here. I tried to draw a really nice circle. There's apparently a shape tool. I didn't use it. Okay, it's original, right? So it's somewhat like a circle. We do a vertical line test. 1, 2. Guess what? You're not a function, Mr. Circle or Miss Circle. You're just a relation. All right, so that's how we handle some of those tests. One more. It looks almost like a $sign. It certainly will after I go and do this. I got 1, 2, 3. Hey, I always point this one out because I'll have some students when we're together in class that say, well, what if I put my vertical line test here? Then it is a function. But what has to happen is it has to pass on every vertical surface. So if there's any one, like the first one I did, that it fails, then it fails completely. Okay, so it's kind of like an all or nothing, like a pass-fail type of thing. But it have to be on all of those. So this one is not a function, so we call it a relation. All right, now that we know about functions, we'll review a little bit. This problem was previously given to you as y equals negative 5x plus 7, and then it said solve if x equals negative 2. So that's what's going on right here. X is being replaced with negative 2. So where I have x, I'm about to put negative 2. So I have negative 5 parentheses negative 2 plus 7. So negative 5 times negative 2 is positive 10 plus 7. So that means I get 17. That means this function evaluated at negative 2 gives me 17. Okay, this part on the left, normally we don't write, right? So you never did that before, but it helps complete that idea that this is an ordered pair. Negative 2 gives me 17 as we deal with this a little bit in Algebra 2. All right, so if you have x needs to be replaced with 4, there are 2 places to put that 4. So now we need 4 squared plus 2 times 4 minus 5. So we just work through here. So f of 4, we get 16 from the 4 squared plus 8 minus 5. 16 plus 8, we're the whole way up to 24 minus 5 gives me 19. So notice I didn't put f of 4 on every single step, but in the end I do want to put that back there. So that means this function evaluated for 4 will give me, right, input output. If we go the whole way back to middle school, the input is 4, the domain is 4, the output 19. So that's the range. All right, so we can make up anything we want. So I might go with 3x squared over 5 and divide it by x over here. So we might deal with some of this. You know what? Let's make it the square root of x just to make it super fun. And the number, now to be fair, since I have a square root, I probably want to pick a perfect square. So I'm going to go with 9. Okay, so 9 squared minus 5 over the square root of 9. So the denominator is plain old 3, right? So I'm going to have minus 5. But here, do I do 3 times 9 and then square it, or 9 squared times 3? 9 squared times 3. Okay, so I need 3 times 81. Now you think, what'd you do that for? That seems really difficult, right? So what's 3 times 8? That's 24. What's 3 times 1 is 3. It'd be 243 minus 5 and divided by 3. So 243 minus 5, we're at 238, right, guys? Over 3, and that's even, that's odd, so we're going to leave it that way because it's not going to reduce. All right, easy enough. So what did that pair up with? Ooh, I drew my box on there a little bit early, right? The function evaluated for 9 turned into 238 over 3. All right, pretty good. We can continue to add to that. So we're going to work with this. So the f and the g just tell me which function to go work with. So that means I need to put 2 into this one. And I need to put negative 3 into this one. And then we'll solve each of these independently. So we know that's 6 minus 2. So I get 4 here. I get negative 6 plus 5. I get negative 1 there. And what are they asking me to do with these answers? Down here, it says to add them. Okay. So now I want 4 plus negative 1. So my final answer is 3. Okay, so working with functions. Then I can also do operations with functions where I actually have to add them together. We could do subtract. So that's why I used parentheses here to make sure that if it was minus, it'd be double negative. So we can be careful with that. All right, so just review what you were thinking today. Make sure you can write 5 ordered pairs. That's still a function. Okay, and then can you evaluate this one? Go ahead and put it right in your notebook, and I'll take a look at that as we get class started.